Okay, so here we are for the battery eliminator for a VTVM. This is happens to be a Heathkit VTVM. The battery circuit is to replace it's just to replace the 1.5 volt battery, so you don't have to worry about, if you're not using it, it leaking, causing damage, or having to replace it. So this is a circuit that I actually got off of another YouTube video from a gentleman, and I apologize, I don't remember his name, who worked for VTVM in their lab, and this is what they used. Now, that being said, I went out and let me disconnect a couple things here so I can show you this. I actually built this little circuit. Okay. So we're going to have the 6.3 volts coming in here, right here. Then it goes through the diode. Yeah, that's better. Goes through the diode right here. It's got a capacitor to ground. This capacitor to ground. I used the bottom holes to solder to as well. Don't forget they're there. You can use them. Okay. Now there's supposed to be a resistor going from here to here, 27 ohm resistor. Okay. I don't have a 27 ohm resistor. I don't have any low ohm 2 watt resistors. Okay. So what I had to do to figure out what I'm going to need is I had to use my resistor substitution box. Turns out it's on 15 ohms instead of the 27. Okay, so I put this all together. Okay, and I checked the voltage coming out. I had 3/4 of a volt. I'm like, what? It's supposed to be at least 1.4. All right, so what am I doing? I changed the resistor setting, nothing. Okay, well, first of all, I went back up. Let me get this up. I went back up to, I got to move the camera a little bit so you can see this here. Sorry for the shaky Jake, but there's 2 terminals. I'm taking it off of the power from the lamp. This is a 6.3 volt power coming into here. So I'm taking it off of here. Always make sure you take it off of the correct side. The left side closer to the transformer is not the side you want to use. Okay? You want to use the other side. Okay? Oh, that was good. I hooked it up there. The problem is I don't have 6.3 volts coming off of here. I only have like 5.8 volts coming out. So that's why the 27 isn't going to work at all. But still, it's so low. So what I did was I made up this, took another diode. Okay. That diode is going to get soldered into here. Okay. It's going to get soldered on to that. There's going to be heat shrink tubing coming over this, and then this will go down to the plus side for the battery. Now I'm going to show you what I'm using here. I'll take these clips off. Okay. So if you look down inside, this is where the battery cup was. Okay, this is the plus side of the battery. I took a little terminal, put that in its place. I know some people mount it up here. I didn't want to drill another hole here. I'm going to use this hole. This is where the negative side was. So right on here, this little screw terminal here is going to go right up inside. Yeah, I'm trying to do two things around the camera. It's going to go right in like that. And then the battery voltage is going to come down to here. So your negative and your positive are going to be connected. It's going to be that easy. Yeah, I know it's kind of hard to see. But that's the circuit. Again, for whatever reason, I'm not getting 6.3 volts here. Maybe the transformer's starting to go. Not quite sure. That leads me to another thought process here. You always got to be thinking. Okay, the two tubes that are in this VTVM, the 6AL5 and the 12AU7, they both pull 300 milliamps. Okay, so they're 300 milliamp tubes. Okay, so we got 6AL5, 300 milliamps. And then you got the 12AU7 is 300 milliamps. Okay, you've got the power on bulb right up in here, which is just a regular incandescent bulb. I'm just going to mark it as a lamp. That's 220 milliamps. That's 820 milliamps before I add this. Okay. I check the current with this on. The circuit board, I'm just going to call it a B plus board, with 60 milliamps. That's 880 milliamps. Okay. Now, it only draws this additional 60 milliamps when you're in the ohms position. I don't know what the current rating is. I don't know what the current rating is on this transformer here. There's nothing in Heathkit's specs that talk about the amperage rating. It gives you a model number. It doesn't tell you what the specs are on the current. So do I leave it like this? This is what I'm thinking. If I leave it like this, I have a potential to burn out the transformer. The other thing is, I don't use the ohms too much on an analog meter because I got a digital meter. It reads out real quick. It's a lot easier to read. I could take this bulb out of here and replace it with an LED, but an LED is still going to pull about 20 milliamps. Okay, well, yeah, it's going to be 20 milliamps, so that would reduce this down by 200 milliamps. So we'd have 680 milliamps of draw if I put an LED up in here. And what did I do? Yeah, 680. With the, okay, I lost track. Never mind. My thought process is right now, I'm going to leave the bulb in. First of all, I don't use the ohms range too often on an analog meter. My digital meter is more accurate, but that's something to consider. Luckily, I've gotten that donor board from Rob, so if I do burn out this transformer, I've got another transformer to put in its place. And I'm going to put this all back together, and we'll wind this project up. Okay, okay. Stop the presses. Stop the presses, everybody. You know, when you make a video and sometimes you're not totally paying attention, you make mistakes. I made a real big mistake in the beginning of this video, and I don't know if anybody saw it. If you saw it, let me know, because you got good eyes. If you want to take a few minutes, go back, take a look at the beginning of the video, see if you can spot it. Look at the schematic, look at the little circuit that I made up, and let me know if you see the mistake. I'm going to continue on with this, so see if you can find it, but I'm going to explain what happened. So when you look at the circuit, your voltage comes in, goes through a diode, through a resistor, capacitor to ground, 2 diodes to ground. The beginning, I was only getting over here, instead of 1.4 volts, I was only getting like 750 milliamps, or 3/4 of a volt. It's crazy. I couldn't figure out what was wrong. I added another diode in the string. Man, voltage went up. Well, didn't hit me right away. But when I tried to use the circuit, the meter pegged backwards, pegged negative. Couldn't figure out what was going on. Such a simple circuit. Well, it took me a while to find out the stupid mistake I made, but I want to share it because things happen like that. If you go back and you look, these 2 diodes, I had put them, this junction into this hole, which then meant that there was actually only 1 diode, which is 3/4 of a volt drop. Okay. This diode here, by putting it into this hole, this is just a solid bar. It shorted this diode out, so it was like the diode wasn't even there. Believe me, it took me a while to find my mistake. But once I realized what I did, it was very simple to go back and make the correction. And sure enough, it's working now. So I'm going to get this soldered in. I've got the schematic calls for a 27 ohm resistor. I've got a 30 ohm. I tried a 22 ohm, 30 ohm. They both given me good voltage on that. So it's about 1.5 volts, which is what the battery is. So it's working fine. So I'm going to solder this in. Again, this point here is going to, make sure the power is off. That point there is actually going to get screwed into this hole from underneath. And then, like I said earlier, the red lead will get soldered down here, and we'll have a permanent 1.5 volt supply for this without having to put batteries in. All right, so let me get that, and then we'll test it. That's the last thing I have to do. Okay, so the circuit board, I'll show it to you once I check the calibration on this. We must get this so that it's, that's why I don't use analog meters for certain stuff, because I spend more time trying to get them set to take a reading than I do and you put the two together, and then you have to put the 2 clip leads together. The resistor's not there. I'm just shorting the leads out so I can zero it. Okay. All right, and go back to the other side. We got to get that right up on 1 meg. Yeah, that's about as good as I can see it from here. We'll try this again, short the leads. That's good. This is I don't know if you can see it or not, but this is a 1K resistor, 5%. Let's see what it reads. It's reading about not even 95. Okay. I give it a little meter tap, a little love tap there. Yep, that's good. That's good. Right around 950 ohms. It's not 1,000. But I've checked this on my digital meter, which I'll show you in a second here. I'll put it on my fluke meter. I'll back this out of the way here, maybe. Let me get this in here. And it's 977 ohms. Again, the analog meter is a 5% accuracy. 5%, it's there. It's within its spec. The only way to calibrate the ohms is to make sure your resistors that are in the circuit are correct. Now, what I did was I went through and I took a reading on all of these so I know what's what. And on the R times 100 scale, it's 2% out. Okay, that resistor is 2% out. I'm not going to mess with it. I don't use the analog meter anyway for ohms readings. I do want to have it on a bench, check something real quick. As long as it's close, I know it. Most of the stuff I'm doing on tube radios, transistor radios, 5%, 10%, it's still going to work. So to me, it's not that critical. Yes, when you get into working on high-end, if I swing around and show you the Tektronix scope I have here, yeah, you better have an accurate meter to test it with. So again, this was something that I wanted to do. Get this out of the way. Swing back. All right. And the ohms is working now. I'll pull the plugs on these. Just give you a quick look before I end this video. And you can see the board is mounted up in here. The 2 wires are coming down. There's no real stress on anything. And there you go. No more need for batteries. I'm going to also put this into my ICO 232 meter and get that working the same way. If you look at my bench, I don't even have that out on the bench. This one I'm going to leave out on the bench since I've done so much work on it. The other one I built back in 1971 when I was in trade school, but I hardly ever use it. This one I'll keep on the bench for a while. Hopefully you guys looked at that circuit, got an idea of what I did wrong. I hope somebody caught it. It took me a while to find it. So hoping that somebody has had sharp eyes and can actually see the mistake that I made. So from the point I started this video, kind of disregard a lot of what I said because a lot of it was wrong. Okay, you gotta be a big enough person to admit when you're wrong. I know what I did. I know what happened. So again, I can't even see myself. Click subscribe, click like, make some comments. Those of you that have been following my site and making comments, you know I respond to the comments. So good luck. Hopefully this was help to anybody else working to build this circuit.